Robot rule power lines. China deploys an army of humanoid robots to control the future of power grid. While many Western nations remain focused on AI ethics, software chatbots, and long term safety debate, China is moving aggressively in different directions, using artificial intelligence in the real world. Now we take a deeper look and break down this entire story on the AI podcast.
Right now, high in the mountains of Guangdong province, there is a severe storm rolling in. I mean, the wind is howling, the rain is just coming down in sheets, and a critical high-voltage transmission tower is taking an absolute beating.
Yeah, that is not the kind of weather any grid engineer wants to see.
Exactly. But instead of a crew of human engineers, pulling on heavy rubber boots, loading into trucks, and risking their lives to go check those buzzing, lethal power lines, a pack of four-legged metallic dogs is waking up to do the job.
Which is just a wild mental image to start with.
It really is. Welcome to the Deep Dive. If you are prepping for a meeting, catching up on the latest tech trends, or you're just insanely curious about where the global economy is actually heading, you are in exactly the right place today.
Absolutely.
Today, we are looking at a stack of sources. We've got investment data, infrastructure roadmaps, and robotics supply chain analysis. And this data completely flips our understanding of the artificial intelligence arms race.
It really reframes the whole conversation.
Because our mission today is to unpack how China is actively deploying a massive army of physical AI systems directly into its national power grid. And we need to look at what this aggressive hardware-first pivot means for the rest of the world.
Okay, let's unpack this. Because we are talking about a shift that makes generating a digital picture on your laptop look like child's play.
We really need to ground ourselves in the stakes here because they could not be higher. For years, the dominant conversation in the West has been heavily focused on software alignment, theoretical AI ethics, and long-term safety debates about artificial general intelligence.
Right, the whole what happens when the chatbot gets too smart debate.
Exactly. But what we are seeing in this analysis is that China is effectively bypassing that theoretical stage entirely. They are taking artificial intelligence and applying it directly to the single most critical sector of modern civilization, which is the national power grid.
The actual physical infrastructure. Yes. The logic is simple, but pretty ruthless. If the grid fails, everything else stops. I mean, the digital chatbots stop, the hospitals stop, the financial markets freeze. By putting AI in charge of the physical maintenance of the power grid, we're moving entirely beyond theoretical debates and straight into high-stakes, real-world application.
I was looking at the procurement numbers we pulled for this deep dive, and I actually had to read them twice.
Yeah, the scale is massive.
Because we aren't talking about a pilot program with, 5 or 6 neat little robots walking around a parking lot. Are they seriously deploying thousands of these autonomous machines into the grid this year?
They are. The State Grid Corporation of China, which, by the way, happens to be the world's largest utility company, is dropping about 6.8 billion yuan on this initiative in 2026 alone.
Which translates to roughly what, $1 billion US?
Yeah, roughly $1 billion. And for that money, they're purchasing approximately 8,500 robots this year.
Wow.
This year. Just this year. That is a staggering procurement number for advanced industrial robotics. And about 5,000 of those are the quadruped robots, the robotic dogs.
Okay. And the rest of them?
The rest of the fleet is made up of highly advanced humanoid robots and these dual-arm industrial machines.
Right. And instead of sending squishy human doctors to fix a blocked artery, you're deploying 8,500 immortal metallic antibodies that don't need sleep, they don't feel the cold, and they don't make fatigue-driven mistakes.
What's fascinating here is that the power grid is the ultimate proving ground for physical artificial intelligence.
That's so.
Well, a lot of the highly publicized robotics projects we see online are essentially R&D vanity projects.
Yeah.
A robot doing a backflip in a perfectly controlled, heavily padded laboratory is visually impressive, sure, but it doesn't solve a macroeconomic problem.
Right. It's just a cool YouTube video.
Exactly. The power grid is the exact opposite of a controlled lab. It is an environment full of unpredictable variables, shifting terrain, lethal voltage. This isn't some far-off future concept for 2040. This is a massive, immediate procurement strategy solving real-world maintenance risks right now.
Because if it works there, it works anywhere.
Precisely. If a robot can successfully navigate a washed-out mountain path to repair a high-voltage line in the middle of a thunderstorm, it can do almost anything.
Which brings us to a massive glaring blind spot in all of this. Because when you look at the investment landscape globally, There is a severe divide. The West is playing an entirely different game right now.
The divide is incredibly sharp, yeah, and the capital flows tell the whole story. When you look at the United States and much of Europe, the investment landscape is completely skewed toward the digital realm. Nearly 90% of U.S. venture capital money in the AI sector goes directly into software.
90%, that's almost everything.
It is. We're talking about funding the next large language models, the smartest digital assistants, and advanced code generation tools.
And we know the energy intensity of those software models is massive, which we will definitely get to. But that 90% allocation leaves a staggering funding gap when it comes to robotics, hardware, and industrial automation in the West.
Huge gap.
While the US and Europe are locked in a cage match to build the smartest conversational agent, China is taking the exact opposite path. They are pouring their capital and state resources into physical AI.
And we can see the results of this divergence in the raw shipping numbers. We hear a lot in the media about Western robotics. Companies like Tesla with their Optimus program, Figure AI, or Agility Robotics.
Yeah, they command enormous media attention.
They do, and they are heavily hyped. But the reality of their output is vastly different. Tesla, Figure AI, and Agility Robotics each reportedly shipped only around 150 humanoid robots in 2025.
Wait, 150 total?
Yes, 150.
Wow.
Now, compare that to China's leading hardware firm, Unitree. Unitree sold 5,500 humanoid robots last year.
That is a massive difference.
It makes them the world's top seller by a huge margin. Because of this focus, Chinese firms now control more than 90% of global humanoid robot sales.
Okay, I have to push back here for a second because I know what you, the listener, might be thinking, because I'm thinking it too. Wait a second, isn't software where the real genius is?
That's the common argument, yeah.
I mean, creating an artificial brain that can reason, solve complex logic puzzles, process billions of parameters, that feels like the hardest part of the equation. If the US builds the ultimate digital brain, why does it matter if someone else is building the metal body to carry it around? Can't the West just build the software and port it over to the hardware later?
That is the exact assumption driving a lot of Western venture capital right now. But it completely ignores the brutal realities of physical supply chains.
Okay, unpack that for me.
It is not just about slapping a smart digital brain into a piece of metal. The physical body requires an incredibly complex manufacturing pipeline. Consider a critical component called an actuator.
An actuator?
Yeah. Think of actuators as the translation layer between digital thought and physical torque. It's a highly compact mechanism that combines a precision motor, a gearbox, thermal sensors, and a controller, all into a single joint.
So it's essentially the robot's muscle.
Exactly. It's the muscle and the nervous system for that joint combined.
Yeah.
If you want a robot to pick up a fragile glass insulator without shattering it, or hold a heavy steel cable steady in high winds, you need world-class actuators. Without them, the smartest AI in the world just twitches violently.
And the manufacturing tolerances for those components are insane, right? You need rare earth magnets, incredibly precise metallurgy, massive heat dissipation capabilities. You can't just 3D print that in your garage.
No, you absolutely cannot. And the global market share on actuators is telling. China controls around 26% of the global actuator market.
And the U.S.?
The United States controls roughly 5%.
Oh, wow.
Yeah. Having the electronics manufacturing capacity, battery production leadership, precision motor manufacturing, and the sensor supply chains, all highly localized means China can take a physical prototype and mass produce it incredibly quickly and cheaply.
Whereas the West can't do that as easily.
Right. The West is relying on fragmented or less dominant supply chains, so they face slow, incredibly expensive hardware scaling. If you don't control the physical components at the raw material and factory level, building robots at mass scale becomes an economic nightmare, no matter how brilliant your software is.
So if you don't control the physical components, scaling up is essentially impossible. But here's the really scary part about the shift from digital to physical AI. Software can be trained in a vacuum.
What do you mean?
Like, you can feed a large language model the entire internet and it gets smarter sitting on a server, but physical robots require physics. They need to step on loose rocks, they need to slip in the mud, they need to miscalculate wind resistance and fall over to actually get smarter.
Ah, yes, the real-world friction.
Exactly. And because China is deploying thousands of these machines domestically right now, they are building an insurmountable real-world data moat.
They absolutely are. Down in Guangdong, at the China Southern Power Grid's robotics laboratory, humanoid robots, drones, and quadrupeds are actively operating alongside human engineers.
Every single day.
Yes. They are gathering real-world operational friction data. They are currently training across 6 major real-world scenarios and 15 distinct skill categories. We're talking everything from complex equipment inspection to emergency response protocols.
Take their flagship robot, Feiyun, for example. This is their specialized quadruped designed specifically for the grid. It is completely autonomous. But to your point about the data moat, it doesn't just have a standard camera strapped to its back.
Right, it's way more advanced than that.
It uses multimodal sensors. This means it is actively overlaying thermal imaging to spot a transformer that is running, say, 5 degrees too hot, while simultaneously using LiDAR to calculate the depth of a muddy ditch.
And it uses acoustic sensors, too.
Yeah. It's listening for the specific microfrequency of a failing electrical joint. It is synthesizing physics and digital logic in real time. And the crazy part is, there's no human standing 50 feet away with a remote control.
No, it is a fully autonomous field agent. When a robot like Feiyun walks on uneven gravel at a substation, it logs that highly specific kinematic data.
And shares it with the rest of the fleet.
Exactly. And because they have thousands of robots doing this daily across diverse climates, their systems are learning to navigate the physical world at a rate that lab-bound Western robots simply cannot match.
Here's where it gets really interesting. They aren't keeping this massive advantage at home. China's Southern Power Grid isn't just maintaining their own backyard.
No, they are expanding.
They have already signed an agreement to deploy these exact autonomous Feiyun robots to remote substations in Chile later this year.
In South America.
Yeah. This isn't just about keeping the lights on in Beijing anymore. This is an aggressive infrastructure export strategy. They're literally putting physical Chinese AI on foreign soil to manage another country's critical infrastructure.
And that raises a crucial question, why Chile? Why is there such a sudden, desperate global market for these robots?
It's not just a PR stunt.
Far from it. It isn't just a flex of technological might. The push to export these machines is a direct response to a looming worldwide infrastructure crisis.
Right. Global electricity demand is skyrocketing, and it is coming from every possible direction. You have the rapid push for EV charging networks, the electrification of industrial manufacturing, rapidly growing megacities. But the biggest, most aggressive wildcard in the room?
The AI data centers.
Massive AI data centers.
The irony is profound here. The software AI revolution in the West requires an unbelievable amount of electricity. We aren't just talking about powering the server.
You're talking about the cooling, right?
Yes, the massive liquid cooling systems required to keep tens of thousands of GPUs running continuously at their maximum thermal limits. The International Energy Agency, the IEA, projects that global data center electricity use will exceed 1,000 terawatt hours by the end of 2026.
1,000 terawatt hours. I mean, to give you a sense of scale, that is roughly equal to the entire yearly power consumption of the country of Japan.
Just for data centers.
Just to keep the chatbots and the image generators running.
And here is the breaking point. The physical infrastructure meant to carry all this electricity is failing. Look at the United States grid. Much of it was built between the 1950s and the 1970s.
It's incredibly old.
The data shows that around 70% of the U.S. grid is currently nearing its end-of-life condition.
Wait, 70%?
Yes, 70%.
So we are building these trillion-dollar state-of-the-art AI supercomputers, but we are plugging them into a wall socket from 1975.
That's a pretty accurate way to put it.
It's like trying to run a Ferrari on a handful of crusty AA batteries you found in a junk drawer. You have aging step-up transformers, microscopic cracks in ceramic insulators, a massive shortage of skilled tradespeople who actually know how to fix them, and rising outage risks. The grid is physically buckling under the pressure of the digital AI boom.
This creates a perfect contrast in crisis management. It reveals the core insight of this entire analysis, really. The West is treating AI as a product, but China is treating AI as infrastructure.
That is a huge distinction.
It is. While many Western countries are bogged down in policy debates and struggling with massive maintenance backlogs due to labor shortages, China views scalable robotics as the immediate physical patch to a grid under unprecedented stress.
Because they can just build more workers.
Exactly. They see a massive labor shortage in dangerous blue-collar jobs. They see aging transmission wires, and their solution is to mass manufacture robotic workers to bridge the gap and keep the power flowing.
But patching today's failing infrastructure is just step one. When you look at their roadmap, the end game is staggering. They are looking at 2030 with a vision for complete, unprecedented autonomy at a national scale.
State Grid has laid out a modernization roadmap that is incredibly aggressive. They plan to invest 4 trillion yuan, that is $574 billion US dollars, between 2026 and 2030, specifically targeted at grid modernization.
$574 billion.
Yeah, that represents a massive 40% increase over their previous 5-year funding plan.
And the timeline they have attached to that $500 billion is moving at breakneck speed. By 2026, they want 30% intelligent automation in key operational areas. By 2027, they are targeting 80% penetration of intelligent agents.
And then there's the 2030 goal.
Right. By 2030, they are aiming for a fully autonomous power grid. Imagine what that actually looks like mechanically.
It's almost sci-fi.
It really is.
Yeah.
A remote substation detects a voltage anomaly. An intelligent system automatically routes a drone to inspect it. The drone confirms a cracked insulator using thermal imaging. Then, a quadruped robot is autonomously dispatched from a local hub carrying the replacement part.
And it coordinates with other machines on site.
Exactly. It coordinates with a dual-arm humanoid robot to execute a live wire swap, all without a single human ever clicking an approve button on a screen. A grid that practically runs and heals itself.
We cannot overstate the macroeconomic scale of what this means. State Grid serves 1.1 billion individual customers. They employ 1.3 million people and generate $546 billion in revenue.
That is just massive.
When an organization of that sheer monolithic size pivots to a robot-first operational model, it doesn't just change their internal company structure. It shakes global supply chains. It single-handedly creates the manufacturing demand that drives the entire global robotics industry forward, lowering costs for everyone in their ecosystem.
The scale is so massive that the biggest players in the West are openly acknowledging it. Even Tesla CEO Elon Musk recently stated that China is Tesla's toughest competition, precisely because of their mastery of both advanced AI and raw manufacturing scale.
If we connect this to the bigger picture, it becomes clear that companies you might not have heard of yet, firms like Unitree, UbTech, Fourier, and Deep Robotics, are quietly positioning themselves.
Getting ready to dominate, yes.
While Western startups are fighting viciously over who has the most articulate, creative chatbot, these Chinese hardware firms are gearing up to be the backbone suppliers of next-generation physical infrastructure worldwide.
So, what does this all mean? It means the true AI race isn't happening in a browser window. The real AI race is about roads, it's about advanced factories, automated logistics systems, and autonomous power grids.
It's about moving things in the real world.
Yeah, it's about who can deploy intelligence into the messy, unpredictable physical world. Not just who can get an AI to write a poem or answer trivia questions on a glowing screen.
It's the stark realization that the future of artificial intelligence will not be decided by software alone. It'll be decided by whichever country can successfully combine digital intelligence with highly refined robotics hardware, back it with massive manufacturing scale, and then actually deploy it into national infrastructure.
And right now, China appears to be running entirely unopposed in that specific race.
They are definitely leading the pack by a wide margin.
All right, let's do a quick recap. We've looked at a massive global divide today. On one side, you have the West pouring 90% of its venture capital into software and digital AI, building massive data centers that require staggering amounts of power.
Power they might not have.
Right. And on the other side, you have China deploying a $1 billion physical robot army. Thousands of robotic dogs and humanoids going directly into the world's largest power grid to maintain that power.
We also explored the supply chain reality.
Yes. How China's dominance in raw supply chains, like controlling 26% of the global actuator market, allows them to mass produce these robots, while Western companies are struggling to scale.
And the export strategy.
Right, how this isn't just a domestic project. With autonomous robots like Feiyun heading to places like Chile, the West's product-driven AI is on a collision course with China's infrastructure-driven AI.
It is a profound shift in how we understand the application of technology. And I want to ask, what stands out to you? Is it the sheer $500 billion scale of the autonomous grid investment? Or is it the realization that the sci-fi robot future we've been waiting for isn't arriving as a shiny butler, but as a rugged machine working a dangerous blue-collar job in a thunderstorm?
It is wild to think about. And as we wrap up this deep dive, I want to leave you with one final lingering question to mull over. We know that the massive AI software revolution happening in the West requires an unimaginable amount of electricity. Data centers consuming the power of entire nations just to keep the liquid cooling systems running.
It's an immense vulnerability.
It is. But If the physical infrastructure and the power grids required to keep those massive Western data centers online are eventually maintained, upgraded, and controlled entirely by another country's autonomous, exported physical AI,
Which is where things seem to be heading.
does the country that controls the hardware ultimately hold the kill switch to the software?
Okay, one question for you. With thousands of robots entering China's power grid, is Beijing quietly taking the global lead in AI by focusing on physical automation while the West remains focused on software tools? Don't forget to comment it. Thanks.